This is a well-known problem. Like, why does it take a disaster to galvanize change? The only kind of positive spin I could think of at the moment is a concept of window of opportunity, which is like, if there's a disaster, then at least we can seize that moment to try to prevent another disaster.
Hello and welcome to Urgent Futures, the show that finds signal in the noise. I'm your host, Jesse Damiani. I'm a writer, curator, and professor who's on a continual quest to learn about reality and how it's evolving. Each week, I sit down with leading thinkers whose research, concepts, and questions clarify the chaos, from culture to the cosmos. My guest this week is Colin Raymond. Dr. Colin Raymond is a research scientist at the University of California, Los Angeles. His work centers on understanding the intricate interactions of weather, geography, and human systems that drive extreme humid heat and its impacts now and in the future. He draws upon a variety of approaches, from direct observations and climate models to storyline development, in the service of producing and communicating accessible and actionable climate information. As many of you know by now, I'm currently working on a book manuscript called How to Survive the 21st Century. Modest, I know. But it's meant as a journalistic effort in which I draw from the insights of experts across a wide variety of fields to sketch the major crises we face today, and crucially, what more effective responses to them might be than what we're currently doing. I've been fortunate to speak with many experts whose ideas I've already included in the book. But as I set out to work on my heat, humidity, and fire chapter, which I have to say is a doozy, I realized I'd never actually had a guest on who could speak to the issue of wet bulb temperatures. These are the temperatures at which it is hot enough to cause the human body heat stress and humid enough to prevent it from cooling off through sweating. Without getting into spoiler territory, a wet bulb event plays a key role in Kim Stanley Robinson's superb Ministry for the Future, which, by the way, if you have not read that book yet, take this as your sign. Jump it to the top of your list. I really cannot recommend that book enough. Given how much of a threat wet bulb temperatures already pose, and the fact that in a heating world, their likelihood is unfortunately going to intensify, alongside degradation of the infrastructure that would mitigate the harms they produce, I knew I needed to address this immediately, which is why I was so excited, though I guess that's sort of a weird way of putting it, to discover Colin's work. Not only is he deeply knowledgeable about the topic of wet bulb temperatures and guides us through the risks they pose to us, but he also has expertise in the broader arena of climate extremes. Just for reference, here are some titles of recent papers he's authored and co-authored. Do summertime atmospheric rivers meaningfully promote humid heat? How might extreme climate events be connected and why does it matter? And how are key compound risks changing in a warming and moistening world? He's also facilitated workshops that seek to surface collective insights about these existential risks. Many scientists are content to stay in their narrow lane, and there's nothing wrong with that. But it takes a really special scientific mind to take this transdisciplinary approach to their work. And that comes through in this conversation. So I'm going to get out of your way and let you hear it directly from Dr. Colin Raymond. All right, I am joined today by Dr. Colin Raymond. Colin, thank you for being on Urgent Futures.
Jesse, thanks for inviting me. I'm excited to see where this conversation takes us.
As am I. I think we should start with the basics. And the reason that I reached out to you in the first place, wet bulb temperatures. This is a subject that people are beginning to be aware of, but it deserves much more awareness. So maybe to kick us off, if you could just start with the very, very basic sort of definition and explanation for what WBTs are.
Wet bulb temperatures are one of many ways that we can measure the combination of variables that affect us when it comes to extreme heat. So the most simple one, of course, is air temperature. Then we have the heat index, for example, which is an empirical formula developed by the National Weather Service. Other countries' weather services have developed their own heat indices. For example, in Canada and Europe, they use slightly different ones. The Humidex, you might have heard about, is the Canadian version. Then there are also more complicated variables that include things like the solar radiation, the wind speed. Wet bulb temperature is sort of a unique one because it is not empirical. It's actually a physical quantity. It is the lowest temperature to which a parcel of air can be cooled using just the moisture that parcel of air or human body or any other object contains. And so because we cool ourselves by sweating primarily, it's an extremely good proxy for how heat stress affects us, how environmental conditions lead to heat stress and the health impacts that causes. It's complicated in a way because even though it does involve only 2 variables as opposed to 4, say, or more that some other heat indices do, different combinations of those 2 variables can lead to the same wet bulb temperature. And they do combine very differently in different parts of the world under different weather conditions, different times of day. And so it's a major and continuing challenge to understand the patterns of wet bulb temperature and, of course, their changes going forward.
And my understanding is, correct me if I'm wrong, that wet bulb temperatures were considered to be somewhat higher than new research is revealing, that actually the effects of heat stress, particularly on imperiled populations, it's actually much lower and into temperatures by number that most people don't think of as harmful or deadly. Can you speak to that?
Sure. So I'm not a physiologist, but I am familiar with the literature that you're talking about. And I think there's maybe a few parts of the paradox, the seeming paradox, that these conditions are harmful, yet we are somewhat familiar with them. One is that the most vulnerable populations are affected by conditions that younger people in good state of health are not. And what that sort of means is that there's a lot of chronic, sort of latent heat stress that's going unremarked upon, that's increasing the risks of stroke and heart attack and other kinds of comorbidities, but haven't traditionally been recognized as heat stress or even things that are contributed to by heat stress. And yet this new research suggests that they very strongly are. There have been some hints over the past few decades. There have been, for example, some studies about how globally people's sleep is affected at pretty moderate temperatures, like 20 Celsius, 68 Fahrenheit. I mean, that's the entire summer, right? In like Arizona or most of the American South, places where people have lived for centuries or millennia without air conditioning, of course. What this points to is that acclimation only takes you so far. Now, the role of acclimation is still kind of an open question. Obviously, we can acclimate. There are limits to acclimation, just like there are limits to adaptation and other things too.
Let's put some ballpark numbers to this. So just to start, what are considered wet bulb temperatures in terms of temperature and humidity combinations?
At a relative humidity of 100%, the temperature equals the wet bulb temperature because it's not possible to evaporate any moisture out of that parcel or that object into the air when the air is completely saturated already. So, for example, in some coastal kinds of areas along the Gulf Coast, for example, you might have temperatures of 85 degrees Fahrenheit. I suppose Fahrenheit is going to be the preferred.
We can do Fahrenheit
Measurement system here. Huh?
Yeah.
Maybe 85 Fahrenheit with a dew point of 75 Fahrenheit, maybe even 80 Fahrenheit in South Florida, for example. And South Florida is fairly representative of the global tropics, at least the coastal global tropics. And those would be relative humidities of maybe 80%. So that's a muggy day for sure. That's uncomfortable. That's not going to kill you in an acute sense, even with some global warming on top of that. But it does lead to chronic heat stress, and there have been some great studies out of South Florida researchers recently discussing this effect of chronic heat on people who are exposed to it all the time, for example, landscapers in South Florida. Then there's the hot and dry conditions. So you can think about, in the end member case, you can think about the American Southwest on a not monsoon day, so the relative humidity is being 10 or 20%. So in that case, the dew points are so low we don't even think about them, 30 Fahrenheit, 40 Fahrenheit. And of course, the temperatures are 110 degrees, something like that. And that brings up the really important point that there are two different ways that heat can generally affect us. There's two different environments, I should say, that are lethal. One of them is the hot and dry case, where we are limited by sweat. So we can only consume so much water, we can only sweat so quickly. So if you were in the shade with an infinite supply of water in a very hot and dry place, you will be able to survive quite readily anywhere on the planet. Of course, the reality is that's not how people are exposed, so those conditions are frequently lethal. But it's not an environmentally limited case. The other extreme is the environmentally limited case, the very hot and muggy kinds of conditions where even if you are sweating, you are not going to be able to cool yourself down to the level we need to survive because the heat and humidity are both so high that when you've evaporated as much as you can out of your body, your temperature still hasn't lowered by the sweat-based cooling to the temperature we need, 100 degrees.
Mm. And can you explain just I'm not asking for like a sort of medical granularity, but just the general mechanics of why sweat cools the human body? Like, how does sweat cool the body?
Yeah, it's very simple. It's just evaporational cooling. So, we evolutionarily hit upon this idea that the other animals, as far as we know, do not have the advantage of, which is when you have something that's wet and air that's not saturated, that water tends to evaporate, just like your wet clothes on the clothesline. As you may recall from high school science, the energy in a bit of gaseous water vapor, is higher than the energy in a drop of liquid water. Where does that energy come from? It comes from the surface or entity that the water came from. So in other words, when sweat evaporates off our body, we're using inadvertently, without any control of our own, the energy contained in our body. In other words, our body heat is being used to evaporate that drop of water. It's being drawn out of our body because that water is moving into the air.
So there's also this, like, sweat requires blood flow, and so when your body's working to evaporate that sweat, it's also your heart's having to work harder, and your circulatory system is having to work harder because it's essentially seeking to send that water out of the body.
Exactly. Well, it's seeking to bring the hot blood near the surface, I think, is the source of the strain.
Got it.
That it's trying to move blood from the interior of the body near the skin, and it starts sort of spinning its wheels because it's not able to get the brain starts freaking out, like, why is this not working?
Right. So let's talk about heat stress then. I feel like this is a natural segue. So under wet bulb conditions, your body's attempting to sweat, your heart's working harder, but it's not working. What are the symptoms and what's the experience of the person experiencing stress?
Yeah, well, I'm not an expert on this, so you should take what I say with a grain of salt. I'll just give a very brief overview, which is all of your organs that are involved with pumping or filtering your blood become stressed. Sometimes it's hard to sort of draw the line between the effects of heat stress directly and the effects of dehydration, which of course amplifies it and is frequently co-occurring with it. There's the organ kind of aspect, and then there's the perceptual or kind of brain side of things, which is you become disoriented, you become dizzy, you become, of course, agitated by the stress that your organs are under, and then people collapse. Usually, at that point, cold water on the body, in the body, is essential. Death can occur when either one of the organs gives out, the kidneys, for example, the heart, or, of course, the brain, for example, via stroke. And it's one of these, as I mentioned already, it's one of these things that I'm sure has happened throughout human history. I was thinking recently about people marching on ancient Greek battlefields, with suits of armor or whatever, just carrying heavy equipment, into the 95-degree Mediterranean sun. I'm sure people collapsed and they just attributed it to weakness or something. So this is something that has surely accompanied us throughout our history, just like frostbite, for example, has surely affected us in cold climates. The main reason we're concerned about it, I guess, is because it's increasing rapidly, the conditions that lead to it, and also the fact that it's increasing in the places pretty much exactly in the world that are most vulnerable to it, where people have the least amount of resources to be able to manage or avoid exposure.
Let's talk about both of those last 2 points you just said. I want to talk about the regions of the world that are most at risk and you've done a lot of work on compounding and cascading risk. So thinking about the way that heat interacts with things outside of heat. And then I'd also love you to answer what's going to read as a very elementary question, which is, why is the risk of heat increasing now?
Sure. So for the first one, the regions of the world that are most vulnerable to high wet bulb temperatures are the ones that have warm summers and a fair amount of moisture that is nearby the region. Often that means that the region is coastal, but it can also mean that the region is subject to something like monsoons, which draw in a lot of moisture, or even just irrigation, for example. So that means, I should say paramount in the world for high wet bulb temperatures, high humid heat stress in general, are the coastal portions of the Middle East. So the Red Sea coast, the Persian Gulf coast, the Arabian Sea, and then kind of moving over there into South Asia, pretty much all of South Asia, the Indo-Gangetic Plain maybe above all. And that's the main area where really high levels of moisture can get super far inland because of the dynamics of the monsoons. There's a lot of really fascinating kind of geographical aspects to all this. It's not just something you can pick off of a map, although to a certain extent you can. Then there's places that are not quite in that same tier, but are still noteworthy. Southeast Asia, for example, the Caribbean, northwestern Mexico along the Gulf of California. So those are all places where probably within 50 years, it'll be impossible to live there in the summer without air conditioning. And I always feel the need to mention there are places, of course, in the world, many places that are essentially impossible to live without heating. When people live there just fine, they pretty much don't go outside or go outside for short periods of time for several months of the year. So we have to, I think, start conceptualizing heat as that kind of thing. The problem, obviously, is that in those places that I just mentioned, many people continue to live without air conditioning, reliable air conditioning, certainly, and even without electricity at all. I've traveled some in the tropics, and you just find yourself feeling like you'd give anything for a fan, like it's so simple, and yet people are living and struggling without these things, and noticing, because in these places, in the tropics, I mean, the variability is so small day to day, year to year, that just a couple of degrees can really push you over the edge from just being able to tolerate something to, having increasing struggles.
Well, and this is where it connects with the social and cultural factors. One thing I've seen across a lot of my research is one of the biggest barriers to making the kind of adaptations we need to make is, folks, particularly, not always, but particularly in older generations who weathered summers or weathered deep winters. They look back and they say, yeah, it got hot. There was a swelter. We rolled with it and nobody died and it was fine. But with the factors changing, those stories and those memories, proverbially, or forgive the pun, don't hold as much water because we live in a changing world. What do you see as the role of these like cultural stories and thinking about shifting the mindset in some places of summer being like deep winter in the Arctic, let's say, instead of being just like a hot normal time where you go on vacation or go hang out at the beach or something?
Sure, that's a great point, and I've been thinking about this quite a bit, and I think it's one of the main ways that weather and climate science should be progressing and is tending in this direction, that we need to connect our understanding of the physical climate to our culture, our cultural and our personal and community values. And of course, no matter how complex no matter what degree of complexity we try to understand the Earth in, I think human society is another order of magnitude beyond that. So this is a really formidable challenge. I would say, to try to answer your question a little more directly, then, there's maybe a few things that come to mind. One of them is, in the past, everyone was younger, or the people speaking are younger, and there's a lot of evidence that older people are more susceptible to heat. So you yourself may have felt that it was fine in the 1950s, but an older person in the 1950s may have had something different to say. They're not around anymore. Another thing is the invisibility of impacts. I think there's just, for several reasons, cultural, technological, there's a lot more visibility of how people are living and suffering consequences of all kinds of hazards, you name it, especially, again, in the more socioeconomically vulnerable strata. So if someone collapsed of heat stroke in the next town over in 1850, unless it was in the newspaper, which it probably wasn't, you're not, or unless, of course, you were related to them or something, you probably didn't hear about it. Whereas now it might be on social media, or people might be commenting on it in other venues. So I think there's a really important role of like communication technologies in both elevating these issues, but also we need to recognize that it creates a perception that is not necessarily accurate. So yeah, those are a few of the points. Maybe you can restate part of your question if I didn't address it.
No, you answered it amply. I want to stay on this compounding risks thread because you facilitated a workshop which looks incredible. I wish I could have been at this workshop, called Compounding, Cascading, and Critical Risks to U.S. Infrastructure and Security. First, if you could describe in a little more detail what the workshop was about, and then if you could also talk about what insights emerged collectively in the course of doing this workshop.
Sure thing, yeah. And the workshop had an intentionally vague title for political kinds of reasons, I should say. But it was essentially about weather and climate extremes and trying to, I suppose, connect some of the disciplines that have something to say about weather and climate extremes in a way that the physical scientists have usually not appreciated. So we have our physical models, right? We set thresholds which are that range somewhere from arbitrary to semi-data informed. But when you say the number of days in a summer when the temperature will exceed 90 degrees in the future will increase from 10 to 30 in this particular place, that really doesn't have any necessary correlation with what actually happens in a particular town, a particular state, right? Like there's issues around cooling centers, there's issues around who actually has air conditioning, maybe the electricity, maybe the utilities are, maybe the utility plant needs like some level of investment if their load exceeds a certain amount that they're struggling to get the bonds for, or something along those lines, right? There's all kinds of basically culture. I mean, there's the narratives like you just mentioned. Maybe people don't, even if there's a cooling center, there's a lot of evidence of this actually. Just because a cooling center exists, I'm a big critique of cooling centers. I think they.
Oh wait, please say more about that.
They don't really solve anything. But people, may not recognize that they are in need of emergency help. So there's all kinds of things that happen, and so just saying that there will be a certain increase in a hazard and then sort of walking away doesn't really solve any problems or avoid anything that sort of is meaningful to people. However, I do believe there's a lot of potential to work kind of hand in hand along the whole spectrum from physical hazards, global warming, if you like, or just, global climate, to, all the way down to the level of like social workers or, people who work at schools, and understand kind of from their perspective what they're seeing, what the needs are, how those might be changing under various, circumstances. And the way that we talk to each other pretty much is kind of through narratives, storylines, and especially what this workshop was trying to do was make those concrete. So really start at a certain point, very specifically, right? You're in town A, such and such happens, and then maybe this other forcing factor comes in. What happens next? And then what happens next? And then so on and so on. And what do we end up learning from that? And I believe there's a lot of unrealized potential there. And I think the workshop results bear that out. Collective storytelling and very intentional, rigorous thinking about how different aspects of our society and decision-making and infrastructure and so on connect is a lot, reveals a lot more powerful insights than just saying, such and such is going to increase, and then maybe the utility will have to do something, and everyone should be thinking about more investments. Like more investments and more thought is too vague to sort of make change, especially when people are sort of hesitant, skeptical, as you kind of alluded to.
So what were, if you don't mind sharing some examples, what were some examples that stood out to you as, examples of these kind of like practical, on the ground responses that aren't just kind of hand wavy, like more investment?
Sure. So one of them, and I had a summer intern actually who did a very similar project as well. One of them was around the World Cup next year. So there'll be games, of course, across the country. One group focused on the New York, New Jersey area, and the final of the World Cup will be at MetLife Stadium, which is in northern New Jersey, just outside of New York. And the group storyline considered, well, if there's a major heat wave at MetLife, even aside from the impacts on the players and so on, just focusing on the spectators, there's going to be a lot of people in town from out of the area, out of the country, who will probably not be acclimated to serious heat and humidity of the kind that New York can periodically get. They're going to be reliant, this is the part that is sticking in my mind, they're going to be reliant on the public transportation system, which even in the best of times is very hot and sticky, right? In the New York subway, all the trains have air conditioning in principle. But then if there's a grid overload and there's a blackout, even if only a few hours in duration, people are going to be stuck potentially on very hot trains. Trains obviously will not be will not be running, so people will be struggling to get around, which could lead to traffic jams. If people are in a huge traffic jam and like they run out of gas, then the car doesn't have air conditioning anymore. So even though only a few factors have just come up in the narrative there, you can already kind of see the complexity, and it underscores one of the many critical points, I think, which is the electricity is just so important these days to the way that we live in North America, let's say. And so many other systems and emergency response actions and so on are predicated on reliable electricity. And there just doesn't seem to be a contingency plan for, again, these kind of mass events, really super extreme events.
And our grids, are from the 20th century, leaving a lot to be desired.
Exactly. Yeah.
So, and also heat impacts the grid as well, not just in terms of the demand itself, but actually extreme heat can harm the grid itself, is my understanding.
Yes, it can harm the grid itself. It can also harm the railroad tracks themselves. Usually once a summer or so, there are delays on the LA metro system because some component, electrical or like a rail tie, has been warped because of the heat.
Right. So when you say something like, this particular region of the world is going to go from 10 to 30 days of 90 plus degree heat, the average person hears that as, that sucks, another few weeks of extreme heat. But actually getting to your workshop, there's this potential cascade of problems that far extend basic discomfort. The energy grid can be impacted, public health outcomes can be impacted. Can you speak to that like broader systemic approach to heat?
Well, it's one that I am a passionate advocate for and am trying to practice. But it's hard. Yeah, it's hard because people who are in the positions to say, the precise details of how a certain local electric utility, water system, city, government, school system may be affected, don't often have the time, right? They're focused on, or the money, right? They're often focused on very pressing local concerns. So another takeaway is there should probably be more resources, and it's hard to say sort of how this would work, but I think with the seemingly increasing prevalence of these events that people are surprised by how they spiral, the many impacts far afield from sort of the neat box conception of what such and such event should cause. With the emergence of those kinds of events, where are the people who are thinking big picture? And unfortunately, this is not a political moment where that kind of thing is happening, but I'm not despairing exactly either, because I think there's a lot of financial and other incentives, but let's just say financial for now, to figure this out. There's a huge amount of potential in responding better, preparing better to these kinds of events. The problem is getting the people to talk to each other and getting the system set up to incentivize people talking to each other in these more productive ways, rather than just different plans on different tracks, or plans that are too short term to sort of account for the possibility of a major super disruptive event. And when I'm talking about super disruptive, like expectation shattering, I'm thinking about Hurricane Helene flooding inland North Carolina. I'm thinking about the wildfires around LA earlier this year. Things that are not that were not judged to be impossible, but judged to be so low probability that it was hardly worth thinking about them. And certainly there were obviously no like real plans for anything from emergency communication, evacuation, protection of structures. It was sort of just throw your hands up. And coming back to heat, I guess the concern is that there could be a mega heat wave kind of along those lines, either in the US or elsewhere, that could simultaneously knock out of commission both like the electrical grid, communication systems, and transportation and other things that would leave us very exposed and very vulnerable.
On a person-to-person level, and this is me asking you to put on like your civilian hat, drawing from your scientist experience. So I'm going into this question sort of owning up front that it's like a speculative kind of opinion question. But I also lived through the LA fires, and even though the home we were living in that we were renting didn't burn down, it's an incredibly traumatic experience. And if you ever needed any illumination that not only is climate change astoundingly real, but that our civic infrastructure is just not there to address it, to respond to it in any meaningful way, some part of me had hoped that would be this wake-up call and that we would start to see like meaningful resilience and adaptation measures. And while there are things emerging in pockets, largely from academia and nonprofits and even startups, as a civic initiative, I'm not seeing anything from the policy level, let's say. And so I guess my like opinion question to you is like, what do you think it will take? You have all this data, you're connected to all these experts, all of whom, and I think what people don't appreciate is that scientists typically, I'm not meaning to speak for you, will hedge toward caution versus alarmism. And so if scientists are sounding alarmist, then it's probably much worse than it even sounds. And so you're connected to all these folks, you're deep in this research. What do you think it will take at this point? I mean, we had a literal fire hurricane and change isn't happening. Like, what will it take?
Yeah, you have really perceptive and thoughtful questions. And this is something that has been on my mind and the minds of many of my colleagues for the last few years, I'd say, but maybe accelerated by Hurricane Helene and the LA wildfires, as I just mentioned. At the workshop last month, one of the things that was talked about is the possibility of a major earthquake in the Cascadia fault zone in the Pacific Northwest, which has not happened recently. There was one in the year 1700, which caused a major tsunami all across the northern Pacific, all the way to Japan. And I believe there are some indigenous, records of that. But of course, nothing major since then. However, people are taking it fairly seriously at all levels of public and private initiative in the Pacific Northwest. So the question, the current theme, of course, was why, right? Almost every other major disaster possibility that one can think of anywhere in the world, people are kind of underplaying when they don't have direct experience of it. And they've had small earthquakes, of course, in the Pacific Northwest, but nothing remotely comparable to the kind that they're trying to be prepared for. And the main conclusion that we had, and we had a lot of researchers from the Pacific Northwest, and we were in the Pacific Northwest also, is that there was an article in the New Yorker about 10 years ago, which very in great detail laid out how different infrastructure failures and social policy kind of failures could lead to devastating impacts. And it was full of imagery of, bridges collapsing and this kind of stuff. And that seems, as far as any of us scientists, social scientists as well as physical scientists, I should say, as far as any of us can tell, that essentially galvanized enough people to become a critical mass to kind of break through to the people who have some capability to deal with this, which is to say utilities, government, and so on, to realize that this is something that they should probably be spending some money to avoid the terrible you know, possible outcomes, even if the chance of those outcomes occurring in any given year is well less than 1%. In contrast, there was wide recognition before Hurricane Katrina that New Orleans was super vulnerable. It's quite obvious. No one knew quite how things would interact, but yeah, I mean, there's a lot of people with limited evacuation routes. Most of the city is below sea level, dependent on these levees. Levees are poorly maintained, or not as well maintained as they probably should be. If it were a place like the Netherlands, right, it's existential. In New Orleans, it's kind of a little more of an afterthought, and that again gets to the socioeconomic stuff, of course. But in any case, FEMA, I believe, hired a consultant firm to do a very large-scale simulation of a hurricane remarkably similar to Hurricane Katrina, and they called it Hurricane Pam. And this exercise happened in 2004, and they laid out in this write-up from discussions with like 100 regional experts, from the utilities to the governments to various social organizations, how that hurricane might impact New Orleans. And they estimated that tens of thousands of people would die and, a million homeless or something. And not as many people died as they thought. But in all other respects, Katrina was like uncannily similar. But of course, in that short year, but still a year between the exercise and Katrina, almost nothing was done. So the question is, why did that not capture people's attention? So it's a very long way of saying, I don't know what it would take. It is, I guess, reflecting on the LA wildfires. Yeah, I mean, it was shocking to, even as someone well aware of these dangers, to see just how far beyond my and the community's collective expectations the fire went, how fast it went. And as I mentioned, I guess, the fact that, in LA, notorious for traffic, there's no major evacuation plans, there's no drills. People live in canyons, one way in, one way out. There's no drills, no anything, no requirements to know things. It's like, why are we doing this to ourselves? And so, yeah, I guess I should say it's not just myself and colleagues who are aware of this. This is a well-known problem. Like, why does it take a disaster to galvanize change? The only kind of positive spin I could think of at the moment is there is a concept of window of opportunity, which is like, if there's a disaster, then at least we can seize that moment to try to prevent another disaster. So in that sense, a small disaster has some silver lining to it. But it'd be better, of course, to learn before the disasters, and that's what narratives and, powerful studies are trying to get at.
Yeah. Well, I knew that I wanted to ask you the following question, and you've kind of teed it up. Have you read, and if you have, what do you think about Ministry for the Future?
I have not read it. It's been recommended to me many times. I suppose that it falls into the category of, it's stuff I think about all the time anyway, so I don't want to do it while I'm getting ready for bed.
Yeah.
But yeah, it's something that it sounds like it was very well written and would probably help connect these ideas even further.
Well, the reason I brought it up in particular, and you know this, but just for the audience, the inciting incident is a wet bulb event that takes place in India and leads to a mass death scenario, which then catalyzes actions good and bad and everything in between. And so you're kind of living in the years and decades following that event. And even though I was familiar with the idea of a wet bulb before that, reading that book was what really grounded it in something practical for me. And I'm from North Florida, where it gets incredibly humid, and I still have family there. And so knowing that people I love are in a place where this could happen was really daunting. And it's nice to think of air conditioning as this silver bullet, but of course, if you're dependent on grid energy and you're having an extreme heat day, it's very possible that either your power will be, doled out. It'll be rationed, or it might go out entirely. And my fear, and you're not exactly disabusing me of this fear, is that it's going to take an event like what's depicted in Ministry for the Future for the public to wake up to how dire a wet bulb can actually be. There are versions, of course, where it seems very modest, although any life is precious. And, if we could do basic things as a society to keep those people alive. But, a lone death or a lone case of heat stress is not going to galvanize the public broadly, it seems. So, yeah, I don't know how to sort of form that into a question. I guess maybe just asking, like, do you think it's going to take a visible kind of cataclysmic level wet bulb event for policymakers and society to kind of catch up to the real compounding risks of heat and humidity?
Yeah, it probably will. And I think it'll be a tale as old as time, in the sense that it's when the rich and powerful are affected that change starts to happen. Yeah, in the US, I suppose that would mean a major heat wave induced, or maybe, tropical cyclone induced blackout followed by a heat wave. And yeah, whether it's mortality or just affecting people's preferred lifestyles, right? It's too brutal to go outside for 2 months of the year, and people start thinking, wow, I can't, enjoy my beach house anymore. Like, maybe this is a real issue. But unfortunately, yeah, I do think there'll probably have to be some real tragic events that, yeah, also involve some level of the more powerful people in society to make the kind of change that is ultimately necessary.
Awesome. Earlier you said that you are maybe not skeptical of cooling centers, but you have some reservations about cooling centers. I'd love to hear those.
Well, it's kind of, I should say that in principle, cooling centers are good. The practice of them, and I've seen this in many places, is almost always closely aligned to checking a box, offering something, and just leaving it at that. And it's almost comical how poorly aligned they are with the actual need. I mean, very frequently this is starting to change, but even today it remains the case that many cooling centers close at 4 or 5 o'clock because they're in a library or a senior center or something along those, or a school or something along those lines. That's actually the time when not only is it very hot and humid, the hottest, most humid time of the day is usually 4 or 5 o'clock. But it's also when heat wave induced blackouts are most likely, because solar power is going down, but it's still, of course, hot and humid. So air conditioning demand is high. So sending people home at that time is a terrible idea. So they should be open until 10 o'clock or something. But the bigger problem is people very radically underestimate their own vulnerability to heat stress. That's not even to mention transportation issues. People who need the centers are unlikely to be able to get there easily under their own power. But yeah, it's really I think something that requires much greater effective cultural messaging, and the messaging right now is very poor, and the availability of the solution is very poor. And something that came up actually in the workshop, and I'm trying not to steal other people's ideas constantly, but one thing that's relevant is it was noted, that with societies comprising many different groups and people having different kind of cultural levers and ways of talking about things, maybe things like cultural maybe there are institutions in our cities that we don't think of as kind of civic resources that could be conceptualized as them. For example, restaurants. And you could have some kind of program where people are given vouchers to go to a restaurant or a set of restaurants, that they like, and then that could kind of help bridge that cultural gap. And, I mean, that's just one thing, but telling people there's a cooling center across the city and it's open from 8 to 5 is not really going to do anything. And there's been many studies that back this up.
Got it. So you started to go somewhere that I absolutely want to go with you, which is basically to steal. I don't know if you listen to the podcast, The Great Simplification, but Nate Hagens will often ask guests, if you were a benevolent dictator and you can make one change, I'm going to broaden it and say, if you're a benevolent dictator and you could sort of influence all US related, heat policy, what are the steps you take? So we'll get there. But the thing I need to ask you before that, just to make sure that we're thorough, is we've sketched a lot of the problems associated with heat stress, with wet bulb temperatures, wildfires. Are there any other either direct or adjacent factors that people should be considering when they're thinking about the subject of heat?
Oh, that's an interesting one. I suppose maybe I'll go back to what I mentioned at the start, which is these more multivariate heat indices. It won't come as a surprise to anyone who's ever been outside that the sun and the wind influence us. The reason they're not part of most heat indices or, communication from the weather service or whatever is that it's very hard to measure something that fluctuates so much in time and in space, one side of the street versus the other, for example. But there have been plenty of like micrometeorological type studies where people carry around little, instruments on their shoulder or something and measure. And yeah, I mean, it makes a big difference. Both the sun and the wind, in addition to the temperature and the humidity. So I think a big frontier is kind of quantifying those and wrapping those into, again, a more social kind of perspective, providing the information to people, not just about what the conditions are, but how much they matter. And then, of course, I guess the hope is that we could then get to the point of, prioritizing street trees so that every block, one side of the street is shaded most of the time, either from a building or from a tree. Something along those lines, I think, is the sort of thing that's possible with current, technology. This is not AI pie in the sky kind of thing. This is just like putting things together that we already have, but just aren't considered important enough to sort of bother calculating.
Yeah, my understanding is like the urban heat island effect, which will come as a surprise to no one, manifests the systemic inequities in in the US. That there can be a difference from neighborhood to neighborhood of as much as 10 degrees Fahrenheit if you live in a more affluent neighborhood that has tree coverage versus if you're in a neighborhood that doesn't have that tree coverage, which is like, I mean, first of all, it creates a total different risk strata. And so not only having that data, but also having that data available to the people that might be now being put at more risk in the particular moment, but then also the broad scale social stuff of like, we need to plant some trees in these neighborhoods.
Yeah, for sure. 100%. And, that goes for everywhere in the world, right? Like there's many kinds of patterns of development and they have their pluses and minuses, but I think wide boulevards with no shade is very hostile to people, and unfortunately those are the exact neighborhoods where the most socioeconomically vulnerable people are shoved or left.
Which brings us very naturally to, you are tomorrow crowned benevolent dictator of heat policy in the US. what are your priorities? What are the first things you do to try to change our relationship to coming to a hotter century?
I suppose I would have to say I would start with our critical infrastructure. I think that's, without having been briefed on it by all my ministers, it seems to me that the risk of an unprecedented kind of disaster related to heat is going to involve, or maybe even hinge upon, failures in critical infrastructure. Again, electricity, transport, to some extent, maybe water as well. If we're talking about, fires, obviously the maintenance of power lines and things too. And the reason that things are in such sorry state of repair is generally that the incentives of the utilities are to, keep things functioning but not really allow much cushion. That's how the ironically named Electricity Reliability Council of Texas is able to have massive statewide outages every 2 years whenever the temperature gets too warm or too cold, because they don't really require any kind of allowance for extremes, and they have a whole system set up to just allow surge pricing but not really incentivize improvements to prevent the need for surge pricing or the possibility of blackouts. So I guess I would focus on trying to work with insurance, utilities, governments, maybe other players like real estate or transportation, to ensure, to come up with some kind of financial incentive, I guess, to have a lot, to dramatically ramp up their maintenance and somehow reward them for a disaster that is avoided. This is another kind of hot topic, I guess, or emerging topic, is politicians say, utility, corporation leaders get a lot of credit for responding to a disaster, but not really credit for or payment for avoiding a disaster. And really, the second is much preferable. So maybe that's what I'd focus on, is credit for disasters avoided.
So just to name some examples. Obviously, I'm pushing you past your subject matter expertise, and I know
tend
that
to speak in generalities because I'm a scientist.
Yeah, exactly.
I'm happy to go specific.
but just thinking about, you brought up you brought up the grid, building in better contingency. You brought up insurers, and so I'm imagining there's also maybe some type of credit for using more fire resistant materials. Are there any other things like that people could be thinking about in their own lives that yes, would be great at the structural level, but also the individual things that people can be doing to ensure that they're more resilient? Are there any examples of that you could share?
This isn't something that is in my core expertise, so I'm not sure if I can give something that's better than what you just listed.
Got it. Fair enough. Earlier, you brought up acclimation. I wanted to spend a little bit more time talking about what the realities of acclimation are and what you see that looking like in the years to come, both in terms of the good forms of acclimation, but also the ways that acclimation might get in the way of resilience and adaptation.
Yeah, that's a great question, and something that is a continuing source of, I suppose, confoundment by heat researchers. And I don't just mean physical scientists, but physiologists, epidemiologists as well. It's extremely hard to measure acclimation in the longer term. In the shorter term, kind of seasonal acclimation, there have been some really nice studies about the timescales and the degree to which people can acclimate to rather typical levels of heat. The answer is something like 3 to 7 days generally. There's a big heat wave in May. At the end of that heat wave, you'll be about as acclimated to another heat wave as you would be in September, for example. So in that sense, we know kind of roughly how acclimation works for healthy people. I think for people with various comorbidities, it's more complicated, and I'm not really sure other than that it's complicated. The big question, and there was some papers, there was one paper in particular from a couple years ago that kind of did the impossible and just sort of laid out why a problem is hard. This is the kind of paper that every scientist dreams of writing, because many problems are hard, but to write about them in a way that is convincing and like publishable in a journal is admirable. But they managed to do it, and they laid out the case of why physiologists and epidemiologists disagree so sharply on a few things. One of them being acclimation. And it comes down to probably data, the kinds of studies that physiologists do involve typically, university students in a lab, right? It's very different than the kind of data that epidemiologists are collecting, and especially the people who are, suffering the most serious consequences of heat are obviously not those same university students, right, by and large. So those are just a few of the reasons. There are these limits, as yet unquantified, to acclimation, and the reason it's difficult to kind of get at those is you obviously can't have a study that kills people. But it seems very an unavoidable kind of conclusion from every physiological model that we have that the mere fact that there is a level of heat stress that people cannot survive means that people also cannot acclimate to that. But if you start incrementally going below that, I suppose it should become exponentially harder to acclimate, but still kind of technically possible. And by acclimate, I mean be able to tolerate something without serious, health impacts, either acute or chronic. So as you kind of nuzzle up to that limit, there's some exponential behavior that is not yet quantified. Unfortunately, with the sort of ministry of the future like events, which we're getting ever closer to, we may have empirical evidence from places like India on how those things look. But right now we don't really know precisely, if suffering through heat, the crazy heat of a summer in New Delhi for 3 months, followed by an even more crazy heat wave, if that's a good thing, or if it's better to step off the plane fresh from London into that heat wave. No one knows, I think, at this point. Just speculation.
Yeah. I hope we don't have to learn the hard way, but all indicators are that we are. So as you said, you can't exactly set up a study like that, but I unfortunately think we won't lack for data in the years to come. I wanted to shift to a slightly different topic, which is I have these 3 recurring questions that I like to close each episode with. And you've inevitably answered them to some degree already in the conversation, so feel free to bring that back in and double down on something or take it a totally new direction. So the first question is, what do you wish people paid more attention to?
Yeah, so I tried to come up with some answers to each of these 3 recurring questions, and I'll try to keep it maybe to 1 just for the sake of time and interest, and not be too centered in my own passions, but
no, please be centered in your own passions. That's what we want to hear.
Well, I want things that people can genuinely pay attention to, and I think would be of broad interest. And so the answer that I kind of ended up settling on was there are these things called heritage data sets, which are almost like cultural monuments to our understanding of the earth and its rhythms. And people, the public, do pay some attention to these, but I was thinking about governments and funding, and some of these data sets are at risk of being terminated for lack of someone to continue collecting them or to store the data from them. with the appropriate context. I mean, for example, there's threats to the CO2 record from Hawaii, which is just, so essential for our understanding of the long-term and seasonal changes in carbon dioxide in the atmosphere. So I was thinking of this question, as I wish that there was a more kind of global system for recognizing which data sets are irreplaceable and valuing them and putting funding toward valuing them in a way that befits their importance.
I love that. What is one resource you would recommend for making better sense of reality?
Sure. So I was thinking about different websites or whatever that I like, but I ended up settling for this one on old school fold out maps. I think that those people have, younger kids these days won't even know what I'm talking about, but those have a lot of potential for connecting things if you study them closely. I'm thinking of the big ones, that are 3 feet by 4 feet or whatever. You understand the geography and history and culture of a place with a good one of those maps, and with a collection of them, there's no telling what you can do.
I love that. And what is one moment when your sense of reality was disrupted?
Yeah, for this one, I'll go back to the LA wildfires. I live a few miles from the Eaton fire, and our neighborhood was not directly affected, but we had really heavy smoke for a few days. And what really disrupted the reality, as I mentioned, was seeing how everything played out with the encouraging stories, but what shattered the expectations was the tragedies, the just complete failures of emergency communication systems, the firefighters being absolutely overwhelmed, the crazy fire behavior, how fast it moved, how far into the neighborhoods it moved from the mountains. That was unforgettable. And I hope, more people are not subject to that kind of experience from fire or other disasters. But of course, I fear that they will be.
Well, I share your hopes and your fears on that front. We've covered a ton today. So first of all, thank you so much for coming on Urgent Futures. Is there anything we didn't hit on that you feel like relates to the conversation? And is there anything you have on the horizon that you are able to share with audiences?
Honestly, I think we hit pretty much everything that I had kind of jotted down as relevant here. Your questions, touched on the major aspects that are on my mind here around the drivers of humid heat and what it means for our societies. And I hope that it's on people's minds, and it's something that we can tackle. I do have some faith, that kind of as a national and global society, we will, I guess, come to the right answer after having tried all others, to butcher Winston Churchill's phrase there. So I'm glad you asked about it, and I'm glad that you've been paying attention to it, because you have a real reach, and I think scaling up these conversations to the level where they are unavoidable by the people who can do something more about them is a real definite path forward.
Well, I appreciate that very much. I'm trying, but most importantly, it's folks like you doing the research so that communicators like us can go try to boost it. So, thank you again for all the work that you're doing and continue to do. And thanks for being on Urgent Futures.
Thanks a lot. It was a real pleasure.
This podcast is edited and produced by Adam Labrie and me, Jesse Damiani. The podcast is presented by Reality Studies. You can learn more by visiting realitystudies.co. And if you appreciate the work I'm doing, please subscribe and share it with someone you think would enjoy it.